So yeah, I'm gonna, last but not least, move on to Brad Folkens, and he's here from CloudSight. They're doing, I think, really cutting-edge work on a unique aspect of the visual AI field, and that's writing full-length captions for images, drawing both on AI and also bringing humans into the loop in certain cases. So I'll let Brad share more about CloudSight's work.
Thanks, yeah, appreciate it. So, yeah, 7 years ago, when we started CloudSight, we noticed something very interesting about the space of AI as a whole. There's a lot of different pieces that come together between memory and listening and speech and thinking and sight. And one of the things that we really noticed an interesting comparison about was that speech recognition or voice recognition didn't arrive fast enough. I mean, it was for decades we were speaking into telephones that were having a difficult time understanding us on those little IVRs. We'd say, help, if you'd say something to the computer, you'd say, do you recognize speech? And the computer would say, did you recognize speech? It had no idea what you were trying to say. It wasn't until these virtual assistants arrived, like Siri and Cortana, where it was a little bit more, we started recognizing that it was more about speech or voice understanding and not just voice recognition. So understanding the entire content and context of what was being said instead of bits and pieces of what was being said. So we started asking ourselves the question, okay, well then why is everybody focused on image recognition? Shouldn't we be focused on image understanding? And so, as in a lot of different ways, if we send an image to a lot of these different types of models, we'll get back, really good responses. It'll say, okay, there's a person in this image and there's some coffee and some wood and maybe some electronics. But then what if we break the mug? And that requires something more. That requires understanding. Wouldn't it be great if we could say something like, well, this is a broken porcelain cup and spilled coffee on a hardwood floor? But this is really complicated. This takes a lot more in terms of the computer vision models and the AI and as we said, understanding. And of course, a lot of different computer vision techniques, they rely on a very finite amount of categories. But if we're going to do something like this, we need an infinite amount of knowledge. We need an infinite amount of understanding in order to describe everything. And so, typically what you'll do is you'll take a finite set of these categories like cat, chair, table, bike, and then you'll pick the one that's most relevant to whatever's in the image. Again, but we live in an infinite world. So we asked ourselves the question, well, okay, instead of accepting failure the first time around, what if we developed a system that could learn through failure? What if we could teach AI in real time with humans as we're ingesting images from the world? And so we started playing around with this idea, which then later became known as hybrid intelligence, or real-time integrated learning, where if you send an image to the system, and we don't know exactly what it is, or maybe the system isn't very confident about what it is, then in real time, usually within seconds, we can send it off to humans and get back a response that's much more rich than what computer vision would typically say. Or if the system responds with something that doesn't know exactly what it is, then the humans are able to kind of fill in those gaps in knowledge. And when we think about it, this is very similar to how we learn as humans. As we walk around in the very young stage, so in the baby infant stage, like we're pointing at things and classifying things and saying, okay, all the balls go in a corner, all the boxes go in another corner. And as we start getting a little bit older, we start pointing at things and describing things. We start asking questions of adults and start learning more and more about the world. So instead of picking from a finite number of classes or categories, we pick from a finite number of words, and then we mix and match those words in an infinite way to describe what's going on in the world. And so to date, CloudSight's recognized over 1.3 billion images, and these are images that we've recognized, processed, and most importantly, learned from. And so what can we do with this? Well, especially in the space of stock photography, we're really interested in this idea of being able to describe and add metadata, very rich metadata, to images that we've seen in the world. And so this is an example of an image I sent through our system. And for this we say this is a white and black Siberian husky on snow-covered ground. And so this is the type of thing that then, if you're building up metadata about your images, this can help your users search that metadata in terms of providing good semantic search around the images. It can help the photographers, because then of course they don't have to go and describe the images too. Here's another image that we sent through the system. This is a brown and white galleon ship scale model, and so this. I was excited about this one because I had no idea that we had anything like this even in the training set, but apparently somewhere there is something that looks at least similar. But you can kind of see how like it's able to piece together different things that are going on in the scene, like this husky. And it doesn't mean that we particularly had an image of that, but it's able to kind of piece together that information based on the other things that it's learned. So to date, we've developed a training set that's one of the largest in the world for the purposes of training captioning. And it's about 500 million images, so about 500 million images, and about 750 million training records over those images. So it's extremely robust, and there's a lot of different images and things and content that we've seen where we've built that into the computer vision models, and now the system performs extremely well over those. A lot of times without humans. So we started off using about 10% computer vision and about 90% humans, and these days we use about 97% computer vision and about 3% humans.
Great. Yeah, and I think this is particularly relevant to the editorial piece of our industry, where I think the tags are certainly helpful, but textual descriptions that obviously do require more validation, are also really important.